Hello friends, welcome to my channel Economica. I, Dr. Gopal B. Saraswat, welcome you all to my channel. Today the topic for discussion is difference between Z-test and T-test. Further we are going to discuss when to use Z-test and when T-test. And finally, we will have a comparative analysis if I use T-test instead of Z-test, then how it going to make a difference to my analysis. So let's start the video. There are different hypothesis testing tools like t-test, z-test, f-test and regression. We already discussed about it. Today we are only focusing upon t versus z. So how to decide which test to use and when? First thing is, you have a population and from that population you will select a sample. So first thing you identify is whether you are aware about the standard deviation of the population, whether it is known to you or unknown to you. And second thing is, what is your sample size? If your sample size is greater than 30 and you are aware about the standard deviation of population, you use z-test. Greater than 30, population standard deviation is known, you use z-test. If it is unknown but your sample size is greater than 30, still you use z-test. So this means that whether your population size is known or unknown, population standard deviation is known or unknown, but sample size is greater than 30, you have to use z-test. But if your small sample less than 30 sample size and standard deviation is known, even then you have to use z-test, otherwise t-test. So from here we can conclude that if my sample size is less than 30 and population standard deviation is unknown, I should use t-test, otherwise in every case I have to use z-test. So how to calculate z statistics? Large sample means greater than 30. So z is equal to x bar, which is the mean or average of the sample, minus mu, average of my population, sigma, that is standard deviation of my population, divided by under root n. N is my sample size. When I put values here, I will get these statistics. If the standard deviation of population is unknown, but you are able to calculate the standard deviation of sample, so then I rather using this sigma, you will use this sign s, small s. And here you will calculate standard deviation using the sample. So this means that we could use standard deviation of sample or population, whatever is available with us. Sample size is greater than 30, we are calculating z or z statistic. But how to accept or reject a hypothesis? This remained a question now. From the previous formula, you calculate the z statistic, z calculated value you will have. You will compare this value with the z critical table value. This is the z table. So if the calculated value is less than the z critical table value, you will accept a hypothesis, otherwise reject it. Further, if you have calculated p value, which is known as probability value, and if it is less than 5%, what is 5%? This is my significance level. I am testing my hypothesis at 5% level of significance. If my calculated p value is less than 5%, I will reject hypothesis, otherwise accept hypothesis. So this is how hypothesis will be accepted and rejected. So let's check a hypothesis, have a hypothesis and let's test it using z-test. Here I am having the hourly wages, not from here, for this one, Z statistic, I am having a daily wages. Daily wages of Ambala and daily wages of Lucknow. There are around 40 wages, the rates I have collected from different locations from Ambala and Lucknow. Let's say I want to check or test a hypothesis that there is no difference in the mean wages of Ambala and Lucknow. I want to compare it. There is no difference whether I go to Ambala or Lucknow as a labor, there is no difference in the wages. So I want to test this null hypothesis. How to do it? First thing is I have to decide which test to apply. First of all, I required n, which is sample size. How many the wages I am having right now in an individual cell? 40. So this is my 40 is my size. So large sample greater than 30, Z statistics. Okay. The next thing is I have to calculate variance of Ambala. How? VAR dot S. Click here. Select the Ambala, control shift down arrow, enter. 3529.7. Similarly, the variance of Lucknow equal VAR dot S, S for sample, and control shift down arrow, enter. 345. So I have to calculate Z statistics, Z test. So how to do? Go to data tab and here you will find data analysis. In data analysis, what you have to do is you just identify this Z test to sample for means. Click OK. Here you just select the everything that required by this value. What is it? The first thing that you require here is the variable 1 range. What is my variable 1? Ambala. So I click here, control shift down arrow, whole range is selected. Next, variable 2, which is what is variable 2? Lucknow daily wages, control shift down arrow, that has been selected. Hypothesize mean difference. If you have population mean and you want to compare the sample mean with the population mean, you can place the population mean here. Otherwise, leave it blank. Variable 1 variance. I have calculated variable 1 is Ambala. This is 3529.7. I just calculated it. Variable 2 is Lucknow and the variance is 3452.1. Levels I have selected, so I click here. Alpha is my significance level 5%, 0.05. And I want my output to be produced on new sheet. So I am naming my sheet Z test. Click OK. Once you click OK, it will produce this result. This is a Z test 2 sample for means Ambala and Lucknow. This is the mean of Ambala, mean of Lucknow daily wages 505, 502. From mean it seems like there is no difference in the daily wages of Ambala and Lucknow. From variance I just calculated earlier. Total number of observation I am having 40. This is my calculated Z value. You can see that. I am just making it okay. This is my calculated Z value 0.18. And I have to compare it with the table value, critical value. Z critical two tail value is available here at 5% level of significance. This is 1.96 or 1.959. Why two tail? Because my hypothesis was there is no difference in the daily wages of Ambala and Lucknow. So when I am saying status quo, no difference at all. That means I am testing a two-tail hypothesis. So when I compare this one with this one, 0.18 is less than 1.95. Then what should I do? I have to accept the hypothesis. And what is my hypothesis? There is no difference in wages of Ambala and Lucknow. So this hypothesis is just got accepted. So you cannot reject this null hypothesis. There is no difference because your z calculated value is less than z critical or table value. Further, next thing for identifying whether to accept or reject hypothesis is p value. So p value I have to identify here, and the two tail p value is here. It is also available with us. So you can see that the calculated p value is 0.85. If I multiply it by 100, that becomes 85%. And this is greater than 5%. Meaning that I have to accept the hypothesis. It is as clear as that. If this is less than 5%, reject, otherwise accept. So this is how these statistics will be calculated using the Microsoft Excel. Moving ahead, next thing is the case of a small sample. If my n is less than 30, sample size is less than 30. So I am aware if my sample size is less than 30, I have to use t-test. So t formula is t is equal to m minus u s upon under root n. M is the same my sample mean, mu is population mean, small s sample standard deviation divided by under root n, which is the sample size. If my calculated t value, this one, is less than the t critical value or the table value, the same thing, accept hypothesis, otherwise reject it. If my calculated p value is less than 5%, reject, otherwise accept. P means probability. So let's find out how to test t. So here I am having this data set of same Ambala in Lucknow, but this time the total number of wages, daily wages I am having is 29 in a series. Total is 29. You can see that 29 from Ambala and 29 from Lucknow. So less than 30, I am going to use t-test. How to use it? The first thing is you go to data analysis. Here you identify t-test pair to sample for me. Click OK. Select the range. And what is my range? Ambala, control shift down arrow. And second is Lucknow, control shift down arrow. Hypothesize mean difference. I am not having population mean, so I am not looking for that. Click here at labels. Alpha means significance value 5%. New worksheet, I am giving it name t-test. And click OK. Once you click OK, it will produce a result before you. Here you have a t-test pair to sample means Ambala and Lucknow. The mean variance and observation is available with you here. Mean difference 508, 502, and the variance is still here. Total number of observation 29. And it is also giving you a correlation coefficient if you are interested in whether both are correlating or not, a very negligible correlation is available here. Next one is t statistic. The calculated t value is available here, and you can see that this t static here, the t calculated value is 0.365. What is my null hypothesis? Null hypothesis, there is no difference in the daily wages of Ambala and Lucknow. So T critical two tail value is available with me here. And if I compare the calculated T value with my table value, 0.36 is less than 2.04. So this means that my null hypothesis is accepted. I cannot reject the null hypothesis. And null hypothesis says there is no difference in the daily wages of Ambala and Lucknow. If I use the p-value option, alternate option, so two-tail p-value is available with me here, and it says the value is 0.71. This means that around 71%, which is greater than 5%. So hypothesis is accepted. So either use the table value option or p value option. You will have to accept this hypothesis. Now let's come to the last point, how Z versus T test. Let's say I am having this data, hourly wages of Ambala and Lucknow now, 40 data points in each category, Ambala and Lucknow. And here I just want to know whether the hourly wages are different or same. Total number of observation in each category is 40. Large sample. N is greater than 30. And total sample size I am having is 40. So as per the rule, I should use Z test. But instead of using Z, I use T test. What happens if I do this thing? Let's check this out. First thing is go to data, data analysis, t-test pair to sample means, click OK, select both the series first series and then second series, 5%. Here I will write Z versus T. This is my new worksheet name. Click OK. Here my results are available. So these are the value for mean, variance and observation. This is my calculated T value. This is T critical, and finally this is my P value. I also bringing here my this table here also, so that we could compare. This is the Z statistic, earlier we calculated for the same data. So I am going to paste it also. So now let's compare these values. How both are same or different. Mean is same, variance is same, observation is same. The t value and z value, there is a difference. This is 0.19, this is 0.18. P two-tail critical is 0.84, this is 0.85. Seems like there is no difference at all. But the major difference is in this value. T critical two-tail and Z critical two-tail. What is the difference we are trying to find out here? This is critical value means plus minus 2.0 both sides of the curve. If my hypothesis, if I am testing a hypothesis here, if my hypothesis is here, either side, left hand side or right hand side, -2 positive, -2 to +2, whatever the calculated value of t, if that is goes to 2, +2 or -2, hypothesis will remain accepted. But in such this category, plus minus 1.96, if my hypothesis calculated value, z calculated value, if it is between plus minus 1.96, then only accepted, otherwise rejected. Let's say my calculated t value is 1.98. So this value is accepted within this line, within this t critical two-tail. So according to this, the hypothesis is accepted. But this same value when comes here, this hypothesis is rejected. But what should happen here? Should my hypothesis be accepted or rejected? Is there any difference between the Ambala and Lucknow? This means that if my hypothesis is true under t, its value is 1.98, calculated t value, if it is within the range, accepted. But actually I was supposed to apply z statistic, and according to z, if my calculated value for the same exercise, I was supposed to use z, but I applied t. So if I compare with the t critical value for the same result, according to this, hypothesis accepted. But actually, as per z's critical value, that hypothesis is supposed to be rejected. So what I am doing is, I am rejecting a hypothesis here using t statistic instead of z. I am supposed to accepting a hypothesis which was supposed to be rejected. Hypothesis must be rejected. This value of z, if you have applied, if you have truly identified the n is greater than 40, and now the value of z, calculated value is 1.98, which is more than 1.96, hypothesis is supposed to be rejected. But as you are using t statistic instead of z, mistakenly you have used it, and this value comes 1.98, which is obvious. You will compare with the t critical. According to this, is accepted. So you have accepted a hypothesis which is supposed to be rejected. This is what happens. So let's do this practically. So here you can see this, the difference between the t distribution and z distribution. Z distribution and t distribution, the basic difference is the peak of the z, the area covers by the z distribution in the peak region is more than what t distribution covers. The peak of t is lower than the z. This is probability density curve. But the t distribution tails are higher than the z distribution tails. Let's check this out. Here if you compare, this peak of z is greater than t, but the tails of t distribution is above than z. As we have earlier seen, the t distribution critical value is 2.0. So tails are bigger. The area coverage in the tails are more in case of t distribution than z distribution. So because of which you may come across a situation that you have accepted a hypothesis which is supposed to be rejected if you have used the z distribution. So what happens then? Error. And which type of error? You are about to accept a hypothesis using t statistic instead of z. So you are accepting a hypothesis supposed to be rejected. You are accepting a hypothesis which supposed to be rejected. So hypothesis is false and you are what is doing? Accepting it. This is type 2 error. So whenever you are committing such kind of mistake, your analysis is suffering from type 2 error. So I hope you like my video. Thank you for watching.